Good afternoon, everybody. For those of you who do not know me, my name is Ali Kujuri, and I'm an adjunct professor at the Department of Engineering Science. In fact, down the hall is the department office, and also one of the organizers of this lecture series. On the behalf of the department and the School of Science and Technology, let me welcome you all to this third lecture for this academic year. And then, believe it or not, it's the 90th lecture since we started the lecture series in 2006. Before I introduce our guest speaker for today, let me make two little announcements. One, the pizza, we have ordered pizza and it's going to arrive at 5:30. How many are you here for pizza, by the way?
Only for pizza.
Kidding. Okay. And then the next lecture titled RF Filter Design Overview is going to be delivered by a senior engineer from National Instruments by the name of Mr. Gregory White. For our talk today, I have invited Dr. Rao in recognition and acknowledgement of the Sonoma State University sustainability. In fact, the week is the week of the 20th, but I invited him to, in fact, to come during that week, but then, of course, he was busy, could not make it. And the title of his talk is Matters, Cradle to Cradle Design and the Circular Economy. Okay. So, by the way, he has brought a lot of stuff for you so that he may show them to you. Now, Dr. Sudeep Motupalli Rao is a chemical engineer who worked in the field in water and wastewater treatment for steel plants in India, as well as research and development of hybrid material coatings at University of New Mexico, Sandia Labs in New Mexico. He worked in the semiconductor industry for a few years in surface metrology and global team development. Design is his passion. He enjoys teaching while learning. He has a bachelor's degree in chemical engineering from the Rural Engineering College in India, a master's degree in chemical engineering from the University of New Mexico, and an interdisciplinary PhD in engineering from the University of New Mexico. So let's just welcome Dr. Rao.
Thank you, Dr. Kajuri. I want to thank you very much, Dr. Kajuri, for working with me and engaging in the conversation, the attention to detail. So I thank you for all the efforts. I also want to thank the Agilent SSU partnership. Agilent is the company that actually makes this financial thing work. So I wanted to acknowledge that. I actually happen to have my office in the former Agilent campus in Rohnert Park, just south of here. How many of you know where Sonoma Mountain Village is? Okay, cool. So it's quite familiar. So basically, when you come out of the East Cotati Avenue exit, when you come to Broadway, just go down a few blocks, and you'll see on the right-hand side an old big campus. So that's where what we are hoping would be an innovation campus. It's called the One Planet Community. So I'll share a little bit more about that. I wanted to get a little bit, before I just rally on into this, I mean, it's good that we have a good, almost full house. There's maybe a few more seats here. People in the back and here can see. I cannot see some people, but I hope you can see the screen. I'm wondering if there is a way to reduce just the lights a little bit, just so we get a better view of the screen. While we're doing that, I'm just curious, how many? Yeah, is that cool? I just want to get a feel for who's here. So I see that there are people from maybe Sonoma State University, and Dr. Kujuri mentioned that there are some people from the technical high school. Yeah, technology high. So yeah, if I can just get a feel for where you're from, just a quick scan. It actually helps because you know who else is here. So maybe we'll start here and then go out and fan out this way, please.
From Sonoma State, junior engineer.
Engineering, okay.
I'm from Tech High, a junior.
Technology high school junior.
Same technology junior.
Yeah, I'm a senior at SSU engineering.
SSU engineering senior.
SSU engineering senior.
Same.
SSU master's program, first, second year.
SSU engineering senior.
Master's program in that.
Computer.
Sonoma State junior engineering.
Sonoma State senior finance and engineering.
Oh, nice hybrid.
Where?
Okay, you're making it happen. Great. Yes, you're also making it happen. Now, you're a student working in the ITB.
Yes, we are Sonoma State students. We work in the IT department.
Wonderful, great. That department actually changed my life back when I was doing my research. I'll share a little bit, but that's really essential service. And Daniel, welcome.
Thank you. Daniel Soto, Department of Environmental Studies and Planning.
I'm with the IT department.
SSU electrical engineer senior.
Yeah, SSU engineering senior.
Junior at Tech High. Junior at Tech High.
Junior at Tech High.
Tech High junior.
Tech high junior.
Same.
Junior Tech High. Same.
Great, thank you. And
Self-employed electrical engineer.
Sonoma State engineering science.
are you in this teaching or learning?
Yeah.
Faculty. Okay.
Junior at Tech High.
Junior at Tech High.
Senior engineering. Also a senior engineer. Senior electrical engineering, computer science.
Senior electrical engineering, SSU.
And my friends Arthur and Chris, my neighbors. Arthur Walsh also works a colleague at Sonoma Mountain Village. And you want to say a little bit, just a brief amount?
Yeah, I am learning how to build export programs to China, emerging markets. So we set up brick and mortar facilities out in Shanghai and Chongqing out in China. And we are building an e-commerce platform that will allow customers to come in and sign up and identify themselves to customers out here. And we're encouraging transactions.
And wine is the first.
Wine is the first product that we're pushing.
And Chris?
I sell dog and cat food.
And you're a great musician. He's a drummer.
And play music. And then my wife teaches geology over here.
Chris Moore, right, and biology. Okay. And you?
I'm SSU electrical.
Are you faculty or student?
No, I'm a graduate student.
We have the master's program also here by the way.
Okay, yes.
SDU electrical engineer senior.
Faculty. Sonoma Academy.
Great, welcome.
Sonoma Academy.
Okay, wonderful. Okay, so I've got everybody here. So thank you guys for coming. I'll try to share what I can, and I hope that you will absorb as much. It seems like maybe Tech High versus Sonoma State, so it's almost maybe the high school students a little bit more. So it's great. I'm glad to see also Sonoma Academy faculty here. So it's interesting. Sonoma Academy is a school right at the base of the Taylor Mountain, actually where I live. So it's wonderful. Hopefully there'll be some collaborations. And Daniel Kabowski.
Yeah.
Kabowski, can I?
Kabowski, yeah.
Kabowski, and teacher, math and science faculty at Sonoma Academy. And sir?
Same, I teach environmental science.
Okay. And your name?
Sam.
Sam, all right. So if you guys have any connections, want to build connections with Sonoma Academy, please do. I love being a hummingbird. I love being a pollinator. And so I believe that it's important for us to gel and network our resources. We're not born alone. Even though we're born one single entity, the best impact we can make is when we are really networked well. So the title of my topic, it has at least attracted you. Maybe you were forced to come because of credits, or maybe because you are inspired by the subject. Matter matters, and matter meaning just mass, things that have mass, things that matter, things that you can touch, tangible. Cradle-to-cradle design and the circular economy. Cradle is what children are born in, we nurture them, and so cradle to the civilization, Egypt, Greece, South Asia, Indus Valley civilization. So we refer to them as cradles of civilization, places that actually fostered growth, emergence. So a greenhouse, a nursery bed where you take seeds and you allow those seeds to germinate, and you nurture them, give all the nutrients, light, water, and all those things. that also can be considered as a cradle. And the world we live in, and I want to sort of maybe plant a seed, maybe if you will allow me, just a question within amongst ourselves, is if we would ask ourselves, what are we here for? And let that question sink in. And I'm not asking what are you here for, because that's a personal question, maybe one-on-one we can have a conversation later on, but if we ask ourselves, what are we here for? Then the answer is a little bit more interesting. And first you identify yourself, now you're not single anymore, it's we, what are we here for? Then it implies collaboration, it implies we need to work, we need to live together, we need to foster life. And so, given the time now, and I don't know if you noticed, is there a typo in the date? Maybe. So there's a 0 before 2014, and it's intentional. It was inspired by the folks at the Long Now Foundation, and I urge you to consider adding a 0 every time you put a date from now on. Maybe in computer screens where you have to pull down, scroll down, you don't have a choice. But everywhere you have a chance to write a date, a year, I encourage you to add a 0. 0 is very powerful. Nothingness is a very powerful concept. The most safest place that you can go into is into your space that you can create where you can block out everything. It's hard to pin your concentration on something. People say, oh yeah, let's focus on a pink elephant. There's no pink elephant in the room, or there's no elephant. Don't think about a pink elephant. You can't do that. You'll still have that thing. So 0, I want you to focus on that because it gives us a chance in time to drop anchor. It gives us a chance to assemble and arrive here in this moment, the 2nd of October. It turns out it's the birthday of Mohandas Karamchand Gandhi. So he was son of a governor, sort of like Jerry Brown. He was also, Jerry Brown's father also was a governor. And, but he did lots of wonderful things with a very simple concepts. Peace is not some insignificant thing, and peace is not something for the liberal arts studies. It's a very important concept that we can learn, and it's the opposite of violence in some ways. But how can you counter that? But it's a beautiful concept that has led to major transformations across regions, individual transformations. So we are putting a 0 there, just saying that, look, I'm not thinking about just a lifetime. I'm thinking about every time that 9999 flips, it's 10,000 years scale. So suddenly you are telling people that, oh, I'm actually looking at my impact. I'm studying, like geologists and others, anthropology, we are studying what happened a long time ago. And you know, designers are thinking about, oh, how do we design things? How do we make buildings, etc. In Oxford University, I hear there's a library where the wood beams last for about 500 years. And when they built that, they apparently planted the trees 500, at the time when the tree takes about 500 years to mature, and when it was time to replace the beams, those trees were perfect, so they could use the wood. So people are thinking along different time scales. I encourage you, let's think about a 10,000 year scale, just to start with. You can think about positive infinity and minus infinity, but I just wanted us to be anchored in time for now. US EPEA is the design firm that I founded in the US. EPEA is a German consulting company founded by Dr. Michael Brongard. He was a chemist. He founded the Environment Protection Encouragement Agency. He wanted to create the enforcement agency. He was a Greenpeace kind of guy, climbed up smokestacks, unfurled banners, did all the protest things, what Greenpeace does. But eventually he realized that it's best to work with the companies to actually figure out, I mean, we all have our passion, but there's no need for us to polarize ourselves and see ourselves as completely different. Just because we disagree, we have some passion, doesn't mean we need to alienate ourselves. So he found out a way that, wait a minute, I can actually work with these companies and figure out and help them optimize and help them get better business, better profits by actually optimizing their process. So he's had success for about 25 plus years. And you know, companies all over, and I'll share a little bit more. So it's based in Hamburg. But Dr. Michael Brongard and an architect in Virginia, Dr. Bill McDonough, William McDonough, architect, taught at the Thomas Jefferson School, inspired by all that we can do. Thomas Jefferson, you guys know, he was an architect. And he was the one who actually crafted these documents that actually enable us as a country. And so there's a certain beauty and elegance and aesthetics to the document. And that is an important concept that I hope that we will take away. It's not the science, it's not the theory, there's something that is unsaid that we can't learn from outside. It's that inner aesthetic. It's that aesthetic that we have about, oh, what is good, what is wholesome, what is beautiful, what inspires you, what touches you, what makes you love something. So what are we doing in the School of Engineering? Dr. Kajuri must be wondering, talking about love and beauty. These all are important because that's how we function. That's the basic currency of us as human beings, as living entities. Forget about human beings. Chimpanzees also have love. They also appreciate it, and tigers and all these, they also have interesting concepts. So bringing those concepts in, allowing those to sink in, cradle to cradle, not just one cradle to a grave. Traditionally, we've thought about it, oh, I want to think long term. I want to think about it, if I make this chair, I want to see how it's sourced, how I make it, how it's used, and at the end, it's grave, what happens, cradle to grave. But cradle to cradle is a more deeper concept, and I'll go a little bit more into that. I just wanted to share, this is the Sonoma Mountain Village right here, just south of here. And for us at US EPEA, developing the business, sharing with clients, sharing with manufacturers. And if you, in fact, you know of anybody who makes products, I would love to hear from them, and I'll give my contact info at the end. Anybody who makes products, anything that, any tangible products. We want to help them innovate. When you make things 30, 40 years, yes, you have a momentum, but you can always optimize. And there are lots of ways we'll see today. And also to build partnerships. One company is making carpets, another company is making windshields, carpet windshields. What do they have in common? I'll share a little bit about later on about a company called Tarkett, how they're taking automobile windshields and that thin plastic in between. There's so much of it that they're actually able to use it into the carpet. So that kind of interesting closed loop systems and circular economy systems are possible, and they're emerging, and it's happening, and it's a wonderful strategy for us to embrace and actually develop skill sets in. So I encourage you to consider these in your own worlds. Even though you're in electrical computer engineering, code is reused. You make code and you reuse that code. You take modules and reuse. So the basic concepts can be applied. This is the traditional paradigm. You take some resources, you take them, you make something, and you dump it. It's a waste resource. There was plenty, and we were exploring in our ecosystem. We were trying to figure it out. We were picking things up, stones, making stuff, and making arrowheads. And now we make cars, and we make bombs, and we make all sorts of things, improvised explosive devices, all sorts of things. But we're still very young in our ability to make things, to fabricate, to innovate. And we do create a lot of stuff. And we live here. We live in this environment. We might not live in that gutter, but that's, what do they say? Some folks, companies, the solution to pollution is dilution. So they take stuff and they just dilute it, or nobody's going to find out. Smog, all sorts of things, emissions. And I want to come back to the concept of the cradle. The earth also can be considered as a cradle. You know, people say, oh yeah, climate change, global warming. Some of you may even think about it that way. Well, I don't have proof. Yes, there's raining, there's earthquakes, there's that. There's, cold, there's more frequency. Yes, Arctic ice caps, this and that. But some things are happening in geological timescale. I'll share only two things with you that I want you to take back, and you can share that as a tool. One, the measurement of carbon dioxide right on top of the volcano in Hawaii, there's the Mauna Lea Observatory. They've been measuring carbon dioxide, and that curves are continuously going up. They go up, small jagged down, go up, comes down. So that sawtooth curve is continuously going up. It comes down. That going up and coming down a little bit, going up and coming down. Can someone suggest why that's the case?
Season. The seasons?
Seasons, yeah. So the earth is breathing, the forests are breathing through the seasons, and so the carbon dioxide does come down, but it's actually cumulatively increasing. So that data is real. The tools that we create, whether it's an HP meter or whether it's a whatever device, it's carbon dioxide we can measure. It's a gas. It's simple. It's just one gas. There are so many other concepts. The second thing, so that is undisputed, and we can look at cores, ice cores, and we can see how we can analyze what was the concentration of the air at that time. And the ice cores also can go back 10,000, 20,000 like years that way, going back and towards negative infinity. And there we can also picture and see how the carbon dioxide levels were. So this is not some spookery, some black magic. No, this is data. This is visible stuff. If I share with you that, hey guys, there's water inside, you might not believe it. But if I shake this guy, you can hear water and you can see water fall out. So that's evidence. So that's, and of course you can drink it and that's proof. The second thing is, how do I know that's carbon dioxide? How do I know whatever? I'll ask you to do one thing. There's a chemistry department here, or even a biology department, or they might have something called an infrared spectrometer. Infrared. And you can even do this experiment yourself. The night vision goggles, you use infrared light, right? Infrared light. But if you have carbon dioxide in between, a screen of carbon dioxide, you can do it with dry ice. That infrared light is blocked because carbon dioxide has, the resonant frequency of carbon dioxide molecules is at that infrared range. So when you try to throw a beam of infrared light, which is basically heat, through a layer of carbon dioxide molecules get excited and they absorb everything. So in fact, in an infrared spectrometer in a lab, in a simple basic science, the way we calibrate that Fourier transform infrared spectrometer is we have to completely block it out. Just like how in a camera, you've got to make sure that your camera is working. You do and you see what it's black. The old good old SLRs. The way we do it in an infrared spectrometer is you put a thin slice of calcite. Calcite is calcium carbonate. It's a crystalline calcium carbonate. It's the carbonate molecule that actually blocks that carbon dioxide. And when you have that crystal there, no infrared light goes through. That's zero. And then, so the transmittance of that infrared light through that infrared spectrometer and how it goes through other molecules and other liquids is how we figure out where the molecules are. So that's just an analytical tool, but it's very simple. So simple that, so the concept is if carbon dioxide is increasing and if carbon dioxide is blocked by infrared, then you can imagine what's happening. We are here, we are continuously bombarded by energy. We radiate energy off. If you were continuously building a blanket of carbon dioxide, some of it goes back in the oceans, but if it's continuously being measured as increasing, so there's bound to be some effect. So that's all we know. So at least just let's go by those two basic points. So why did I spend time? Because it's an important matter. Why should we care? We care because this is where we live. Aesthetically, yes, but also because we are thinking about a longer time scale. Yeah? Everybody with me so far? Anybody dropped out? No. I just want to see if I can go back. Okay. I'll just pause here for 1 minute, yeah? I have first-hand experience seeing these smokestacks. When I was a kid, 6 years old, my dad was working in a caustic soda plant which makes sodium hydroxide. pH is 14. And they made that caustic soda through the mercury cell process. We don't use the mercury cell process anymore in the US. Mercury cell was used also in Japan. And back in the decades ago, Japan's bays were filled with mercury that created lots of contamination. And I saw the effect, swimming pools of mercury, salt water on top, you zap it with energy, sodium amalgam, you wash it in water, you form sodium hydroxide and chlorine gas. Sodium hydroxide and chlorine gas used for bleaching sugars unnecessarily. Sugars are beautiful when they're raw, helps you from diabetes. the raw, unbleached, unfiltered, unprocessed sugar is the best. So I saw that and the impact of the health of my own father and impact on other people, and we see that in other people as well. And right when I joined engineering school, just like some of you guys are in high school, you might go into engineering, some of you are already in school. For me, that was 1984, and on December 1st week, December 3rd or 4th morning, 20,000 people just got, 10 to 20,000 people just got extinguished. Anyone just? It was a plant. There's some seats here, yeah. Come on out. And methyl isocyanate gas was mixed with big tanks, and water was mixed with it. Water mixing with this actually creates an exothermic reaction. Endotherm, exotherm. So exothermic, creating heat. So in a closed container, you're adding water, it generates heat, water, heat, steam, pressure, boom. And the industry didn't have, the plant didn't have Union Carbide's plant, didn't have the actual guidance to the communities. Hey, if there's something happening, if there's some accident, whatever, this is where we assemble. In this case, I think you all know, exit is there. There's only one exit, right? And we assemble outside in case there's a fire. You know, watch out. There's restrooms here. There's one stairs here. We all share some contingency plans. In this case, the people were running towards downstream to the wind. So the wind and the plume of gas was going in the same line as these people. So major impacts, and so there's lots of impacts like that. So I see all this, and this is where I'm joining engineering school like you, bright-eyed, bushy-tailed. Oh, what do? I want to be a chemical engineer. What kind of a chemical engineer do I want to be? So that's sort of the question that I had. So let's skip through, and I'll try to go through in a much more smoother pace. So all this time you might have heard of sustainability and smaller footprint. I say sustainability is not a very inspiring concept. I want you to consider that. Sustainability made sense some decades ago perhaps. I want us to think beyond sustainability. We want to see, rather than a smaller footprint, minimizing, shutting doors, this and that. Yes, we need to do all the optimizations for energy, water, materials, all those are important. But the focus, if we're trying to get to zero, we will never get there. In this way, zero impact, zero imprint. We always want to think of how can I make this building make more energy than it's using. And then you will definitely go to zero, you'll surpass zero because you're aiming for something positive. And so rather than think about a smaller and smaller footprint, which focuses on efficiency, rather than do the wrong thing very efficiently and very well, let's do the right thing first and then build on that. So minimizing this, optimizing that. So that's eco-effectiveness. 3 simple principles for the cradle to cradle. Cradle to cradle. A product is designed from a cradle, goes through its process, and goes into a complete. At the end of its one life cycle, it goes back, gets disassembled, and goes back into another life cycle. So it's a continuous circular economy. 3 simple concepts to guide us. Waste equals food. So if waste equals food, it can't be something else. So the concept of waste is eliminated. If it's food, that's what it is. So anytime we have our bins in our houses, we all have, does anybody have a blue bin, a black bin, and a green bin in their house? Is there anybody who doesn't have those 3 bins in there? I'm just curious, not to embarrass you, but I'm just wondering. So you to know what bin do you not have? Is it going to be the green bin? That's just one. It's just one box. Daniel?
Apartment building with 2 dumpsters, one for recyclable and one for landfill.
Gotcha. So there's an opportunity for Daniel to create a composting initiative and then get the apartments to move forward. And you might be in maybe in an area that's is not served by a municipality or.
I thought you meant in the house proper. Complex has recycling.
Gotcha. So then maybe in your individual home, maybe perhaps you can easily get. And usually these agencies are giving these buckets and boxes for free. So it's just that it takes us some effort. So the concept of waste is eliminated. Nothing is waste. The mass of the earth is finite. When we look at it from some far away, When we saw it from the moon and other places, it was a pale blue dot. You might have all remembered this Neil deGrasse Tyson, who teaches, shares in the episode Cosmos. If you haven't had a chance, check it out. If you're interested in science or existence, it's a beautiful show. It's called Cosmos, and I believe it ran on the Fox network. It goes through a beautiful few cycles. And the earlier version of Cosmos by Carl Sagan referred to the Earth as a pale blue dot, because that's how it looked from far away when we took pictures. The Earth was just a speck. So it's a finite mass. We have finite resources. And yes, it's huge. We think it's flat, but it's actually round. But it's a small marble, and it's a small dust. And so it's finite. So we have resources. So the concept of waste doesn't make sense. So I say let's recycle that concept of waste. Use current solar income, or we can think of it as, because we have the Calpine geothermal energy. How many of you have been to the Calpine geothermal or are aware that it's one of the world's largest, or probably the largest? Actually, yeah, Dan and friends are going tomorrow, and you've been there before. So it's a large geothermal facility down underground. There's a nice, beautiful source of energy, and it's continuously we can get some certain amount of energy from the earth. So there's any renewable energy, any energy that you can already harvest that you're not taking from some future generations. Remember we were saying that zero before 2014? So when you think about future generations, if it's a useful thing for someone else, then let's not try and, if it's a fruit and you have it, you're hungry, eat it. But if it's all the fruit and then there are other people in the boat who need that fruit, then we want to share it. We want to figure out how to share it, right? So earlier we talked about carbon dioxide, global climate change, etc. There's another way of looking at that equation. So we don't even think about climate change. We don't even think about hypotheses and theories and evidence of melting glaciers, whatever. To hell with the polar bears, you may say. But deep down, we have this ancient fuel that plants and other organic matter that was submerged, compressed, high temperature, high pressure, it became oil, gas, coal. These fossil fuels are there forever in the earth, can be there forever as our reserve. It's our battery. It's our intrinsic energy that we can get anytime. What if there was a way, the single most powerful energy source for the earth is, somebody said something. The sun. But what if, in the nighttime you don't have the sun. Occasionally you get the moon, full moon, once in a while you get a little bit of light.
The waste we generate?
That's also a source of energy. The single most largest source of energy, of course, is the sun. Huge amounts of energy density. So much sun, there's a few square miles here and there, if we have enough, if we can really harvest the sun. The reason the sun is so powerful is because it's a nuclear fusion and fission reactor. Continuously hydrogen, helium, fusing, fusion, fission. So that nuclear reactor is far away, far enough that we don't have to think about it. Don't go sitting nude in the sun out there for 20 hours. You'll get cancer because our skin can't dissipate the energy. So there's a nuclear reactor far away, good enough. Let's use that nuclear energy. Forget about putting nuclear energy in small little machines, your small appliances in your kitchen. That's too much. We don't even know what to do with our nuclear waste, but there's no real large repository. So renewable energy, use that. That's what we want to use. Celebrate diversity. Not diversity, just diversity of individuals, ideas, but diversity of ecosystems and industries. And I mentioned about nutrients. So biodiversity, cultural diversity, conceptual diversity. Just like in nature, we can have also an industrial ecosystem where we have diversity. So these are just an examples of what different companies that have absorbed, that have really been inspired by Shaw Carpet Company, Philips, of course, you all know the lighting, and the healthcare company, Steelcase Furniture, Deso Carpet Method, right here in San Francisco, Xerox, and so Aveda Cosmetics. So there are a lot of companies, there are about a few hundred products that have gone through this iteration where the company and the CEOs and also individual folks in the company say, hey, how about we look at this concept where we think of it as a circular economy? Let's examine everything we do, everything that we are purchasing, everything that we're using, our home, offices, in our industry, and let's make products that are beautiful, that leave a trail of beauty and a positive footprint. Let's aim for that. And so there are lots of companies who have been doing it in the cradle to cradle. So you may be asking me, what is this green and blue? It's a certified mark. It was designed, it was of course the founders are Michael Brongard and Bill McDonough. They formed MBDC, McDonough Brongard Design Chemistry. It's in University of Virginia. And the cradle to cradle standard is now administered by the Cradle to Cradle Institute, Products Innovation Institute in San Francisco, right here. And there are a few handful of companies that can do analysis, etc. So those are just small essential things that I need to share. So biological nutrients, technical nutrients, an important concept, just like how nature can really circulate things, keep things in continuous circulation. We can also adapt and move our technical nutrients, our roof tiles, our construction materials, bricks, and others. Some of you may have heard of LEED, Leadership in Energy and Environmental Design. Yes, how many people have heard of that? 1, 2. So it's a design framework for buildings where when you build a new building now, pretty much everywhere in the country and maybe in the world, people are asking, how are we making these buildings, especially if it's planned well. Pretty much almost every architect is aware that we need to do something about how we use materials because buildings are a huge deal. We spend a huge amount of our energy in buildings, and so Leadership in Energy and Environmental Design looks at the ratings, looks at the water, looks at the place, how that building is, and the community, the materials, the energy, sunlight, east, west, and the flow, opening doors, windows. So there are lots of LEED platinum, so platinum, gold, silver, there's some ratings. So LEED is a framework for buildings, and you can think of cradle to cradle as a design framework that has been applied to products. So you come across, if any of you are interested in engineering and architecture, building, civil engineering, LEED would be an, or even if you want, when you eventually will buy homes, you'll see the concept of LEED will come in because you want to try and live in a home that's healthy for you and also for others. An important ingredient is the materials that are chosen in the building, that they're healthy. So we'll quickly go through what those are. So just some products could be a consumption product where it just diffuses, biology absorbs it, and sometimes it's a service product. You use it, like if you buy a gas cylinder now, we have a small carbonator at home. So you buy the cylinder, you carbonate your water, and at the end you return the thing back. You just got that as a service. You're only buying the gas, the cylinder belongs to the manufacturer. So it's a service product. You go to get an x-ray done when you go to the dentist, they have a small little pouch here to protect your thyroids. That's made of? A little louder so everyone can hear.
Lead?
Lead. And lead is plumbum. Lead is high molecular weight, dense material, used in car batteries, used everywhere, used in fishing, and for lead weights. It's also easy to mold into things. But lead also has, it has impacts. Anyone knows what the impacts of lead are? Toxin. It's a neurotoxin. So lead has impact. When you're exposed to lead, now lead after the 70s, I think 73, after that no more paint. Paint no longer has lead. So these kind of heavy metals have been removed. But when you go get your x-ray done, you want lead, that bag filled with lead. You're not going to consume the lead is just there as a service product. You use it, remove it. So lead is not bad. It's a neurotoxin when you consume it. When it's used in an X-ray protector, it's a perfect product. So that's another concept that I want you to also take away is things, materials, elements, energies, people, we're not really intrinsically bad. It's how we apply them. It's how we apply ourselves. So smaller footprint, just ignore it. As long as you capture the larger framework. So some of you may be here, maybe thinking about different disciplines, biology and chemistry and other things. So we assess that for the ecotoxicology, and we look at how when organisms are exposed to it, what happens to mammals, what happens to the fish, what happens to other organisms. So we can individually say, hey, I'm an American, I have my own property, I have rights to my property, I can do whatever I want with my pets, with my children, with whatever, with my spouse. And I'm going to do whatever, I'm going to spray whatever in my lawn, for my plants. And we may have the prerogative, and we may think we have the rights to own. When we pass away, we give it to someone else. But it really doesn't really belong to us, and we can't really put a border. If this gentleman has a farm, and this gentleman has a farm, and he has a way of making his farm, and how he's pollinating his seeds, and how he's growing, and how he's growing, and how she's growing, we have impacts, because even though we have a fence between these farms, the bees and the butterflies don't have any barriers. Wind carries his pollen into his field, and her rats into his field, and all sorts of things. So biology has no borders. And so when we think about, I'm going to spray whatever I want, we want to think about, okay, even in small quantities, what are the impacts? And we also want to look at what's happening to us, and look at the data we're getting about looking in the Bay, San Francisco Bay, lots of pharmaceuticals. It goes through the public waterworks, but we can't take pharmaceuticals out. We don't have that level of, we have a primary treatment, primary treatment, take the solids out, secondary treatment, take all the chemicals out, tertiary, disinfect the water. But we can't go take water to the point of actually going to removing pharmaceuticals. The breast milk of an average American woman cannot be sold in the market now, because the FDA will not approve, because it has so many trace chemicals. So what has come to our, Luis, come on and have a seat. So what has happened to our system of making things and consuming things? And you may say, well, it's such a small amount, it's trace amount, so who cares? But it matters. It matters to us, right? If it has a small amount, it has cumulative effects, and maybe it has some synergistic effects. So it's a question that we want to ask ourselves. So before you think about, I'm going to spray whatever it is, let's ask ourselves, what are the impacts of what happens over time, what happens in conjunction, and what happens that we don't know. What we don't know is also an important matter, and we don't want to bury our head in the sand. So exposed organisms, is there any mutagenicity? Mutations. And we can make mutations happen. It's very easy. You can take your egg or your sperm, expose it to some ionizing radiation, and you can guarantee that offspring you get will get some problems. We can do that intentionally, but do we want to do that unintentionally? Developmental toxicity. As the person is healthy, gets exposed to stuff, and has developmental issues. Reproduction. Even when a person is in the womb, if they're getting something, they can get something through the umbilical cord when they're inside as well. Food chain. Our animals and small organisms eating it up and accumulating over time. Small organisms, mercury in the atmosphere, whether it comes from volcanoes or from coal smokestacks, eventually metal mercury ends up forming inside this mud. And that metal mercury gets into protein. It's a lyophilic, so it's actually fat soluble, and it gets into the protein tissue, it bonds with the protein. Metal mercury doesn't come out easily. Mercury will go out of your urine and your feces, but metal mercury gets into your tissue. So if you are hunting for fish, and you get fish close to a place where there's metal mercury contamination, you can't take the skin off and just eat the flesh, because the skin may have other things, but the metal mercury is in the protein. So we're impacting the very food we eat, the very places we live. So those are some of the things that we want to think about when we are thinking about why we want to go into thinking about a closed-loop circular system, and thinking about what kind of a design we want to have for the materials and the products we have. Also, that's why accumulating in breast milk I mentioned, material flows, origin of the resources, limits. We are finding that phosphates, we are having some metals for our cell phones. It's only coming from 1 or 2 countries. There's all sorts of wars, politics, and countries hoarding those resources. And so resource constraints and people changing their entire ecosystems for just putting some monoculture and building something, palm oil plantations and stuff, a diverse forest, and that impacting. And whatever happens to the industrial and natural environments, the actual hazard of the process itself, because it's important for us to know that even the people who are making things also are exposed to stuff. So it's also important to think about the occupational safety aspects. This is just an example, one way of profiling materials. What I want you to take about it is, initially our products and materials, we screen them, we can screen them, I should say. In the beginning, it's not characterized. We say, oh, we know this is for this particular purpose, for this product, it's not acceptable. This is tolerable, let's improve this, let's optimize this, and that's good. So just like a stoplight chart. So that's just a way of characterizing. This is courtesy of our friends at Method, the company that's now doing amazing stuff, and they are just a small, innovative startup, and then now it's become so big. They got acquired by a Belgian large company, Ecover. And just the space of, when we go and buy stuff, we want to figure out, we want to use some sort of third-party certification. When we buy coffee, let's say for example, it's fair trade certified. Sorry about the print, it's somewhat small. If it's organic or not, if it's Green Seal certified, and if there's environmental design for the environment, the US EPEA has a way of checking to see if it's USDA organic, US Department of Agriculture organic label. So these are all the way. Wood, Forest Stewardship Council, and here we're just looking at the space of this certification space with respect to groceries, cosmetics, personal care, home care, apparel, wood, furniture, appliances, electronics, and Energy Star. All your washing machines, refrigerators all have the Energy Star. And in this x-axis, the responsibility, fair trade, and green, biodegradable, aquatic toxicity, carbon footprint. And at the end, the health, cancer, and all those kind of things. And Cradle to Cradle, because it's comprehensive, encompasses all these frameworks. And these are just examples, and I'll skip through them because there are so many hundreds of examples. But hardwoods have a way in which the water molecule cannot penetrate because the wood has a certain microstructure. And these guys at Accoya figured out how to take a simpler wood, like a pine wood, and process it in such a way that the wood changes the microstructure. So even though you're starting with a simple wood, it resembles a hardwood. And so it's an innovation that you can actually take what you have. We can make the best out of what we have. And so rather than take something from somewhere, ship it millions of miles, Fiji water. I know people celebrities carry Fiji water, all these things. Water shipped from some country. San Pellegrino, shipped from Italy with glass bottles. And those glass bottles come here, we just throw them, recycle them, but we're shipping glass bottles filled with water, H2O, from Italy to here. It costs you $25 to put your suitcase on a United Airlines flight from here to the East Coast. Imagine what all this is. So there's a lot of considerations for Aveda Cosmetics. They started off in the Ayurveda, an ancient Indian science of medicine and health. And so Aveda, science of health, longevity, and they actually design products from the scratch, looking at every single thing. What is going inside? What are the ingredients? And how do we enable our customers to have healthy lives? And how do we make that beautiful? Be Green Packaging, pulp. So rather than using styrofoam and stuff like that, using pulp, boom, compress, compostable. Ecover, I shared with you earlier, Method, parent company, G Diapers, rather than filling landfills with diapers with poop inside, that poop is composting. By the way, if you ever do babysitting or if you're parents, you realize that the diaper that you've taken out, if you let it sit in your house for more than a few days, it'll stink like crazy because all sorts of chemical reactions are happening there. Imagine what's going to happen in a landfill. But the unfortunate thing is, it's so important that we need to actually monetize on that. Your baby's poop is precious. It's value, it's tremendous value. We're allowing those gases to escape and become methanes and other things. and they end up becoming actual global warming, all this cows and dairies, we allow all these gases to escape. We have a lot of dairies in our Northern California and Sonoma. There are so many dairies. We can actually take all the gas from all this biogas and make it valuable, generate hydrogen. So many of you in the tech high schools and engineering, let's figure out how to help our local industries to use the resources we have to make the things we need like hydrogen and use it in fuel cells. This is a diaper insert. It's simple, sort of. And carpets, these guys are in Switzerland. Give me 1 second. Go ahead.
Well, I was just curious, that last comment. Do you believe it's possible to restructure our sewer system to capture that poop and reuse it?
Great question. Let's just, I want to save that. It's a great question because it'll lead us into the Q&A, and I want to share about our system by which in modern civilizations we have these pipelines for poop and for rain, combined sewer systems from the rainwater and also from our drainage, and black water, gray water. There's lots of interesting conversations, including solid waste. So we'll get to that as soon as I'm done. Carpets in Switzerland, their little end cuttings were actually considered as hazardous waste, and the company had to optimize, and they changed it to a way in which the fabric can actually separate into two components, and that components could be used. One component is a technical nutrient, the other component is a biological nutrient. So through innovations, people have moved to products that can be reused, and bamboo and other things. This is a New York company that uses glass and also concrete, and they make beautiful tiles. And these guys are and method, once again, really starting from scratch. Simple chemical engineering, simple chemistries, and really small amounts. 50 loads. Look at that. That bottle is only so small. Before 50 loads, we had to carry a huge jug from wherever we buy our groceries. Now, in such small bottle, good chemistry, good design, we're able to get multiple loads. And one thing I want to actually share about, if I can, when you do your laundry, I urge you to look at that cap. And the cap inside you, and read on the laundry detergent how many loads it says. And I urge you to actually keep a small checklist. Every time you do a load, you put a check. Like a prisoner in Alcatraz, just keep how many checks you get and see if it correlates. The cap has a little line. It says 1 load, 2 loads. Just do an experiment for yourself. I suspect you will never reach the number that they will say. Sort of like fuel mileage in a car. That's because it's a very optimized number, and those lines are not very clearly visible. And so you end up using more. Even though you think we're getting 180 loads, you're getting only much less than that. So, but for the manufacturer, it's okay. You're spending more, you're using more. But ultimately, we're letting detergent go into the water. So for us, it's affecting our pocket, as well as unnecessarily trying to clean up our drains and our water systems. This is silica gel in our packets. Rather than silica gel just being thrown out, this is a material that actually is a desiccant. It actually absorbs water. Play equipment without polyvinyl chloride. Polyvinyl chloride is a very complex material, has got a lot of interesting history, and right now we make a lot of it. It's got problems when we make it, also when we use it, and sometimes when you burn it. When I go back to India to see my parents, I see people burning plastic fires all over the place for warmth, for cooking. And if you're using PVCs, you're creating all sorts of dioxins and poor health. So there are lots of concerns, but there's a way to keep things in closed loop. There's a way to keep things in an efficient way. Instead of using polyurethane foams that have some issues, you can use some sort of latexes, and instead of buying brand new bottles, just buy the cartridge. And surfboards made of biofoam. And I mentioned Tarket. There are ways in which we can take automobile glass. When an automobile glass breaks, it doesn't shatter all over your car. There's a thin film that holds that glass in place. That film, there's so much in the country that there are tons and tons that they can actually use it on these carpets. Similarly, other fabrics, I'm just going to skip through them. And so this innovation is right at the wood that this is in Netherlands, where they have to create these barriers between water and land because the sea level is so close. Sometimes the land is below sea level. So they have to create these barriers. The main hardest thing where wood rots is not necessarily in the inside, but right at the border where the water, soil, air interface. So they just treated the wood right on the top wood. And so this wood can stay inside. So they can use, rather than use some expensive woods or etc., they're just treating the wood right where it meets the air-water interface. And that does the job. So it's intelligent design. So that's Van Swoy. And surf wax, this is simple surf wax. These guys created out of, nothing happens to that surf wax if some animals eat it. So very simple. Start off with a surfer, and she got an idea, and boom, she created the surf wax that it's biocompatible. This is my daughter, Sequoia. And we named her Sequoia, my wife and I. Sequoia trees are, do you know anything special about Sequoia trees?
Large.
Largest, someone said large.
Longest living.
Longest living. So not only are these the largest things, living things, but they also live longest ever. There's never been any living thing in past fossil history that lives long. So we are thinking about her as, just like any baby, we all want babies to live forever. And so we want to foster life. So we want to do life-centered design, not death, not the other way, but life. So that's what I'd like to share with you is, they have so much life and they're swimming around like tadpoles in life. And so we want to help these little babies forever. And so how do we do this? For all babies of all time, of all species, forever. That's the sort of the design challenge we have, whether it's Buckminster Fuller or whether it's, it's our question. So those are the challenges we have, and we can make, and we must, is what I hope. There's some information about the Sustainability Day coming up right here in Sonoma State University on Tuesday, October 21st at the Green Music Center, and also maybe in some courses here and there on campus. So it's coming up real soon. Today is the 2nd. And also there's another Safer Consumer Product Summit in San Francisco at the Marines Memorial Hotel on 22nd and 24th. I'll actually be chairing an innovation forum there. So check it out. I'm here. Skype is a good way to reach me. Just write and say, hey, I heard you talk or whatever, then I know who it is. I try not to respond to LinkedIn and Facebook requests that are generic. So say something about who you are and what the context is. And there's some information at US EPEA, and Twitter is a good way to sort of share. And there are two hands, and I know that I've come to the end of our time, but I hope you'll indulge me, and I thank you for your attention, and I thank you for the opportunity. Thank you, Dr. Kajuri, and all your friends from SSU, from Sonoma Academy, and friends, neighbors from the Tech High School. So thank you guys for your attention. You had a question, and Arthur had a question about it, but let's hear your question, so maybe we can use.
What do you do exactly as the EPEA chemical engineering?
We're looking for people who are interested, like you. The main work is to help companies optimize their products. So I've set up shop here at the consultancy, looking to grow, looking to add people who have energy audit experience, water audit experience, material audit experience, certifications, and looking for someone in the business skills. If there are people that you know who are good at business and marketing and finance. We're looking to grow, and we're helping customers. Customers are asking, hey, I make this, I know my product is good, but I want a certification. Help me, Sudeep. I want you to look at all my process. Here are all my bills, here are all my bill of materials. Tell me how to optimize it. So we help companies optimize their products and then help them create the assessment report so that they can get certified. If they don't want to get certified, that's okay. We help them optimize their process. And it gives them a chance to examine and look at their engineering is all about changing things, not channeling. Chemical engineering is materials. You take some material, you change it. And so mass transfer, energy transfer, mass balances, energy balances. And so you see what's coming and what's going out, where the gaps are, and you try to optimize and figure out, oh, how do you, asking open, appreciative inquiry. What if you do this? Why are we doing it this way? Just inquiring. So we're helping companies optimize. Arthur Walsh had a question about, oh, diapers, etc. Is there a way in which we can make this more efficient? You know, if there's a way. There is a way, and I want to just also share, there's a way to do cloth diapers, by the way. For Sequoia, we've been doing, she's now 7 months plus, we've been doing cloth diapers. There's a service called Tidy Didy, and we have brand new cloth diapers not brand new, washed, clean. They come in a clean bag. We use every few hours, we change the diaper, more often than a regular diaper, less diaper rash for the child. And whatever the diaper, waste diaper, we put in a can, put it in a bag. Every Wednesday they come and pick it up. It's a service, the industry will wash it, bleach it. And yes, there is some amount of washing, but maybe there's a way in which they can optimize their washing and we can have a continuous flow. I would much rather prefer a continuous flow using as much renewable materials rather than this poop going somewhere. For me, that diaper is not waste, it's a resource. If I'm not able to recapture that diaper waste, then I am misusing that food. So the imperative is not because we're creating landfill waste, not because, oh, there's landfill waste or that's a waste. No, it's a food that I'm not able to capture. And so that's why we don't use disposables. And another auxiliary to the question is, in many modern civilizations, we have, even in rural areas, we force a person, you can't extend, you can't build. Even Sonoma Mountain Village, Rohnert Park says, oh, we don't have a main massive sewer line, so you can't build homes. But if you're in the remote jungle, if you build a house, you can do a good job of keeping things in flow. You can reuse the water, the gray water. We built an eco center in Heron's Head Park in Bayview Hunters Point in San Francisco, and I was involved in it for a few years. It's LEED Platinum, and it reuses the water. It does some settling, and that water is purified through a wetland approach, like the way the wetlands clean water, and we use it to water the plants in the surrounding area. So gray water systems are laundry water and dishwater, and even the poop water is black water, can be processed, can be used through bacteria, using bacteria, fish, aquaculture, all these aquaponics, interesting hybrids are there. And countries like Thailand, India, China, places where colonization has forced a mass pipeline sewer system. And even in San Francisco, where we have a combined sewer system, when it rains heavily, San Francisco has to treat not just all the poop water every time the 740,000 people flush, but also the rainwater. But it becomes so overwhelming to the wastewater treatment plant, they say, sorry. So the poop water and the rainwater goes into the bay, San Francisco Bay. That's poor design. So even though we have a collective sump below the embarked area, etc., we have huge reservoirs, but if it reaches a certain threshold, we're sending poop water and rainwater out. So there are intelligent ways in which we can avoid this system. Even in India, we don't have enough water, but we force everyone to flush their toilets. There's not enough water. It's like half flushed poop water. I'm sorry I'm saying about all this waste, kind of what we think is waste, but it's stuff that organic matter is not getting used. And these countries like China and India, there's so much potential for using all that organic matter rather than creating diseases and people slipping over and doing also and stepping on that and creating all sorts of illnesses. We can harvest all that organic matter, both from biological waste from the houses, where you separate. So if you guys have a single passion in your life, you want to make a big difference, what you can do is help countries like Brazil, China, India, and developing countries create simple composting programs. And that can make the biggest impact ever for diseases, for illnesses, for energy consumption, even for helping individual entrepreneurs in villages, etc. So I hope that addressed your question also, yeah. And Arthur, I know that we are sort of getting there at the end. There's one more question, sir. Yeah. Thank you.
Do you think that microbial fuel cells are a good idea to maximize on natural waste?
I don't know much about microbial fuel cells, but one can imagine that a fuel cell is where we are using we are bringing some things together using catalysts and bringing some materials to create energy and to create materials that are safe. So, you know, you can get a hydrogen fuel cell. The output is just water. So you're bringing oxygen and hydrogen together, it generates energy, and the output is water. So biological fuel cells also are an interesting concept where you're using bacteria. In fact, there's a company right here in San Rafael, friends of mine, Blue Eagle. You can check it out, blueeagleclean.com, I think. This bottle contains some trillion bacteria. It's a cleaning agent, does much better job than any of your industrial cleaners out there. This is a floor cleaner. They have a drain cleaner, sump cleaner, they have a bilge cleaner, dumpster cleaners, and this is all bacteria. So even if there's, you know, your kid or the cat drinks on it, they may have some dysentery, but it's not going to kill them. But it's safe, biocompatible, it's compostable. So there are interesting things like that, and this is Cleanwell. They use, Cleanwell uses this herb. This is thyme. I took it from my kitchen. My wife is complaining, where's that thyme bottle? And this is thyme. Thyme has a disinfectant property. So if ever you go to a hospital or an office or any place in your life, if you see a hand sanitizer, if it has alcohol, there's no need to use it. There are non-alcoholic. There's no alcohol here in any of these products. And even these hand cleaning agents. So there's a reason why we are capitalizing on bacteria, because that is 3.8 billion years of R&D that nature has done. So it's a smart way to go and use nature. So cradle to cradle forever. So we want to have a healthy life. We want to have a healthy life for our families, our ecosystems, our communities. We want to create beautiful communities. So thank you for coming. I hope this has been useful. And if there's anything that you need, please contact me. And Dr. Kajuri, I pass it on to you.
I would like to thank Dr. Rao for his very interesting and also informative talk, because, you know, I mean, this one was like a class, and I learned how to be more effective for the environment, and then basically help out the environment and make a difference. And I really thank him for delivering such a beautiful talk. Okay, so let's give it a